Hello everyone, welcome to the next lecture on the June 2023 CSIR UGC examination. Today we will discuss the part 2 and we will cover all those questions which is related to the linear algebra. Myself Dr. Harish Garg. You can simply follow my YouTube channel and you can simply scan and join my WhatsApp group for the various discussion. What you will find on my YouTube channel, there is a playlist of the CSIR UGC net. Here you can find the previous year questions, that is a memory based question, previous year's last 12 years papers solution related to the linear algebra, differential equation, real analysis, complex analysis, partial differential equation and many more. All are you can see in this playlist. So we can see now in this part we will see about the June 2023. So the first question is related to here. V is the vector space of the two variable, is a polynomial of the two variable like x comma y over the real. Then what is the dimension of at most L? That's a very simple. How you can think about that? So firstly I can tell you a simple shortcut tricks based on which you can find any of the polynomial of degree here. So if I say this is my at most degree n, then the dimension, the general formula will be n minus number of the n plus number of the variable combination number of the variables. For example, if I say in this case how many variables? Two variables. So this is my 2. What is the degree at most? L. It is at most m. So it is a L. C number of the variables. So this is the right answer. So if you open them, it is L plus 2, L plus 1 over 2 factorial. So you can see which is that. This is the right answer. Otherwise, you all know a degree of polynomial x comma y is at most the 2. What are the bases? 1 x, y, x square, y square, xy. You can see how many variables are. What is the degree? Is 6. Dimension is 6. And if you apply this formula again, L is my 2. So 2 plus 2 is here. So that is my 4c2, again 6. If you want to find a polynomial of 3 variable, at most say my 2, then number of the variables are my 3, degree at most 2 is my here. So that is a 5c3. Again 5c3 is nothing but my 4 over 2, that is my 10. So what are the bases? If you write like 1 x, y, x square, y, y square, xy, x square y, y square x and y cube. So how you can see 3 plus 3 plus and here you can see this is the y is repeated. So there are the 10 pair are. So this is the simple formula, you must remember it whenever you have to find a polynomial degree less than equal to n. So accordingly you can find this question here. So this is the general formula, you can solve it. You can also see if I say polynomial of degree 7 of the single variable, what is the dimension is? 7 plus 1, 8. And if you look about here, n plus 1, c of 1, again it is n plus 1. So this formula is applicable, it's the general formula for finding the dimension of the V. So I hope this formula will helpful for you in this coming examination as well. Okay, look at this another one. A is a 5 cross 5. This is a diagonal block is given to you. So firstly it is a 5 cross 5. And these are my diagonal blocks. So I can written this as a diagonal block here. This is the first diagonal block. Second diagonal block is written from here 0 e 0 0 0 e. Rest values are my 0 0. Then which of the following is my correct statement? So look at that first. What is the eigenvalues? So eigenvalues are my e how many times? 5 times. So arithmetic algebraic multiplicity of the lambda is my 5. The first option is correct one. A is not diagonalizable. So how you can check that? You have to find the algebraic multiplicity of E is 5. If we are able to find the geometric multiplicity of E, if this is not equal to 5, then we can say it is a not diagonalizable, otherwise it's a diagonalizable. How you can find the geometric multiplicity? There are the two methods we already know. This is a 5 cross 5, 5 minus rank of A minus EI. But here this is not the A, this is my diagonal matrix. So how you can find that? The second method is the number of the Jordan block corresponding to the eigenvalue is equal to the geometric multiplicity. That is a simple rule about that. Now you can count the number of the Jordan block. So this is the first Jordan block, this is the second Jordan block, this is the third Jordan block. So how many Jordan blocks are there? That is 3. So geometric multiplicity is my 3. So 2 is a cancel. So since geometric multiplicity is 3, which is not equal to 5, so it is not a decimable, is also the correct option. So A, B and C are my correct option of this example. Okay, look at this one. P is a polynomial of degree at most 10. This is there. So the dimension of V is my n plus 1. 10 plus 1 is 11. You can see again the same formula. N, number of the variable is my 1. So you can see a polynomial of degree x. So it will be number of n C1, that is 11 C1 is 11. A mapping is given to you as of here. So we can define 11 cross 11 matrix. So what are the bases of this? 1x, x square, x cube up to x9 and x10. So what is that? Mapping is given to you as derivative. That's a very simple. So look at the first basis. If I consider p as 1, derivative will be 0. That's a constant. Rest all values are my 0. If I consider p as my x, the derivative will be my 1. So corresponding to 1 is my here. Rest all values are 0. If I consider the polynomial as x square, basis x square, the derivative will be 2x. The coefficient is my 2. Rest values are my 0. Similarly, if I consider as x cube, derivative will be my 3x square. So 3x square is 3. Rest values are my 0. Similarly, if I consider x raised to power 10, it's a 9x raised to power 9. So it is my 9. Rest values are my 0. Fine. Now you can see the last row is my 0. So it means if I call this is my t, then the determinant of this is my 0. Once the determinant of t is 0, how many number of the non-zero rows? That is a 10, because it's 11 cross 11. What are the eigenvalues? So rank is my 10. Fine. Trace, you can see what are the diagonal values. The sum of the diagonal value is nothing but my trace. So trace is also 10. Determinant is also 0. All the eigenvalues are my 0 because it's an upper triangular matrix. So diagonal and trace are my eigenvalues. So all are my correct options of this example. Okay, look at this one. T is my 3 cross 3 real matrix such that characteristics polynomial is my P of t, and P of t is divisible by t square. So what is the meaning of that? The characteristics polynomial in terms of the x is divisible by t square. So definitely it will be x square of something. Then only it will be divisible. Now it's a 3 cross 3. So the two eigenvalue I have corresponding to this as a 0, 0. The third eigenvalue I can consider say alpha. Now this alpha may be the real or it may be a complex. But we all know complex number, if alpha plus iota beta is my eigenvalue, then alpha minus iota beta is also the complex value. But there is only one number. It means complex number will not be there. It means the third eigenvalue is alpha. All are my real. So all the eigenvalues of the A are real is the right answer. So what is that? Now A cube is a 0 or all about that. So it means the two eigenvalue must be 0. Third eigenvalue will be alpha. Fine. So if I consider this is my A, for example, then what is the A cube? You can see easily. If what is the eigenvalue of the A? Eigenvalue of the A are 0, 0 alpha. Eigenvalue of the A cube is my 0, 0 alpha cube. So I can say what is the A cube? Clearly say that all the values are 0, but this is my non-zero. Fine. So clearly say that which is my, this is my non-zero, which is nothing but A, or say alpha square, which is nothing but is non-zero, because alpha is my non-zero. So its alpha cube is a 0, is a wrong state. Alpha is a diagonal. How you can see that? So what is the algebraic multiplicity of the alpha? Is a 1, so which is same as that of the geometric multiplicity. What is the algebraic multiplicity of the 0? 2. Now you need to find the geometric multiplicity of the 0. If it is also the 2, then it's a diagonal. Now if I consider here, it is 3 minus rank of A minus 0 I. So if I consider this matrix, what is the rank of this? It's a 1. So 3 minus 1 is a 2. So they are same, but this is only the one particular example. If I consider this number as say my 2, for example, then what is the rank of the A minus 2i? There are the 2 non-zero rows. Then the rank of the A minus 0i is my 1, because there are the the rank will be my 2. So then 3 minus 2, then the geometric multiplicity of this 0 is my 1, which is not equal to 2. If I just simply consider this example, again the eigenvalues are 0, 0, alpha is here. Moreover, if you consider simply this example 0, 0, alpha, 0, 0, say A, B and C, then clearly says that the rank will be my 2 and geometric multiplicity is not equal to 2. So A is not diagonal, is a wrong answer. Eigenspace, that is a geometric multiplicity of 0 is my 2. But look at that, if I consider this example or this example is not equal to 2, because it is a 1 which is not equal to 2, is also the cancel. Right option is only my A is the correct answer. Okay, which of the following is my equivalent, positive, definite and here? So very simple, we can say A matrix is equivalent to B over the R when rank of the A and rank of the B are same. Second property, signature of the A and signature of the B are same. What is the signature is? The difference between the positive eigenvalue and the negative eigenvalue. Now we can define over, if it is over the R, then these are the two properties. If it is over the C, then only the first property is enough to prove that equivalent. Now you can write the equivalent matrix of the Q1. Diagonal values are my 6 and 6. Half of this 13, minus 13 by 2, minus 13 by 2. Look at the Q2. What is that Q2? 1, 2, half of the coefficient of the xy. This is my here. What is the Q3? 1, minus 2, minus half, minus half. Now we can find the rank of this. Clearly say that determinant of the Q1 is non-zero. 36 minus this. So what is the meaning of that? Rank of Q1 is my 2. Determinant of the Q2 is 2 minus 1 by 4, again a non-zero. So the rank of Q2 is my 2. Determinant of Q3 is again a non-zero. So the rank of the Q3 is my 2. The first property is satisfied in all cases. Now we can find the eigenvalues. How you can find the eigenvalue? We can check about the principal minors. The first principal minor is 6, which is greater than 0. Second principal minor is the determinant 36 minus 169 over 4, which is less than 0. What is the meaning of that? It is negative definite, because the first principal minor is positive, second is negative. What is the meaning of that? One eigenvalue is positive, second eigenvalue is negative. Look at this. The first principal minor is 1, which is a greater than equal to 0. Second is 2 minus 1 by 4, which is again a greater than 0. It means it is my positive definite. The both eigenvalues are my positive. First principal minor is greater than 0. Second is my minus 2 minus 1 by 4 less than 0. It is a negative definite. One eigenvalue is positive, second eigenvalue is negative. So what is my signature? 1, 1, 0. Signature is 2. There is no negative root. What is the signature is? 0. So signature 0, signature 0. Rank both are same. Q1 and Q3 are equivalent. So first option is cancelled. Q2 and Q3 are positive definite. Only Q2 is my positive definite. So the right answer is my B and C are the right answers. Very simple elementary questions they are asked in this June 2023 linear algebra. Okay, look at this another one. Again, this is a very simple question. V is a finite dimension vector space. T1 and T2 are my nilpotent matrix, such that V1 is here, V2 is this. Then which of the following statement is my false statement? Fine. T1 is similar to T2. What is the meaning of that? Characteristics polynomial of T1 is same as that of the characteristics polynomial of this. Or you can say the minimal polynomial of this minimal polynomial of t1 is same as that of the minimal polynomial of t2. Now you can see what is that. This is represent about the nullity. So we can say what is the minimal polynomial. Minimal polynomial always represents about the geometric multiplicity of the eigenvalue. Fine. What is the eigenvalue of this? Is a 0. So it means geometric multiplicity of the eigenvalue 0 in the t2 are same. What is the meaning of that? Nullity of t1 is nullity of t2. What is the meaning of that? Once the nullity are same, there is a finite dimension, so rank will be finite. You can see the dimension of t1, that is the w1, is same as that of w2. What is the meaning of that? Once both are dimensions same and they are finite dimension, it means they are isomorphic to each other. The first option is my correct statement, but we need a false state. Look at the second part. If w1 and w2 are isomorphic, what is the meaning of that? Dimension of w1 is same as that of dimension of w2. Fine. Then are the same minimal polynomial. How you can think about the minimal polynomial? Either you can define the characteristics polynomial or you can define the number of the Jordan blocks. That's the same thing for here. Now if I consider the two example here, like first example I can since here 0 0 1 0 say here. Fine. And second is similar to this, I just interchange my row here 0 0 1 0 0 0 0 0. Fine. Or I can more simplify. I can simply take this is 0 and this is my 1. Then what is the dimension of this? It's a 4 cross 4. Rank is my 2. Nullity of t1 is my 2. Nullity of t2 is also my 2. Rank is also 2. Rank is also 2. It means the dimension is my same. It's satisfied. Now nullity are same. Does it implies the minimal polynomial? That is not always true. Converse is true. If minimal polynomials are same, nullity are same. But look at that. How many Jordan blocks are there? 1, 2. So it means their minimal polynomial is lambda square. There are 2 Jordan blocks. Look at that. 1, 2, 3. The minimal polynomial of this is my cube. So it means the minimal polynomial of t1 is my here, which is not same as that of the minimal polynomial of this. So second option is false. Thus if second option is a false, it means this is my correct option. If w1 and w2 are isomorphic, that's the same examples, then t1 and t2 are similar. Again you can see minimal polynomials are not same. It means they are not similar to them. They are not isomorphic of them. It means t1 is not isomorphic to t2. That means they are not similar. So this option is also false. So this is the correct state. If w1 and w2 are isomorphic, again the same example, then they have the same characteristics. That's a simple result, because you can see the characteristics polynomial of this is lambda 4 r4, and moreover this is the standard result. If w1 is isomorphic to w2, the corresponding characteristics polynomial are always same. So this is my true statement, this is my false statement, this is my false. So right answers are my B and C are the correct option of this example. Okay, look at that. A is my 3 cross 3 real matrix, which on the following statement is my false. So this is my 3 cross 3. Then the first option is A must have a real eigenvalue. A must have a real eigenvalue. Okay, so if you find the characteristics polynomial of A, it will be a cubic equation. Fine. And we all know a polynomial having the odd degree polynomial must have at least one real root. That's the simple property we all know. Now the characteristics polynomial has the root. What is the root of the characteristics polynomial? That is the eigenvalue. So since it is a cubic polynomial, so that it must have at least one real eigenvalue. This statement is my true statement, but we need a false statement. If determinant is a 0, then 0 is the eigenvalue. That's obvious statement, it's the correct statement. if determinant is my negative and 3 is my eigenvalue, there are the 3 eigenvalues. If 3 is my eigenvalue, then A has the 3 real eigenvalues. Okay, so if I consider this is my complex number, say alpha plus iota beta, this is also the complex number because they are occurring the pair. What is the determinant of this matrix? 3 alpha square plus beta square, which is greater than 0. So but we need a less than 0. So you can see, so whenever determinant is less than 0, it means none of the values are complex. It means both the values are my real. So then both the values are real. It may be alpha 1 and alpha 2. Then the product has at least the 3 eigenvalues. That's a correct statement. All are my real eigenvalue. This is the correct statement. The only left option is there, which is my false. That is the right answer. And this is the explanation of this. If determinant is my positive, then A has a 3 real eigenvalues. That's not true. Yeah, I can simply take, if one eigenvalue is iota, other eigenvalue is minus iota, then what is the determinant of this? 3 minus iota square is my 3, which is greater than 0, but eigenvalues are my complex number as well. So the right answer is my 4, which is actually the false statement. Okay, look at this another one. T is my linear operator. F is my here. Consider the two statement 1 and 2. Which of the following is the correct? Okay, look at the first statement. T is my non-zero and one eigenvalue is my 0. It's a R cube. So T is my 3 cross 3 matrix. One eigenvalue is my 0. What are the other eigenvalues? If I consider alpha 1 and alpha 2. Okay, then what is the characteristics polynomial of this? Fx is my here. So what is that? I can written as x minus alpha 1, x minus alpha 2. Alpha 1 may equal to alpha 2 or it may not equal to alpha 2. Then fx is my here, then g of t. So what is my g of x? This is my g of x. If I compare this with here, so x minus alpha 1, x minus alpha 2. Fine. Then our target is to prove g of t is my 0. This is we need to check. Very simple. If I simply consider alpha 1 and alpha 2 both are same, say 4, or you can see any of the number, I can say 1, a simple 1. So, or for more simplification, I can say alpha 1 is my 1 and alpha 2 is my minus 1. So what is my g of t? So that is my, what is my g of x? It is my x square minus 1. So it is my t square minus 1. Fine. Or you can simply take another number. If I say this is my 2, this is my minus of 2, so it is my this a square, this is x minus 2, this is x plus 2, x square minus 4. Fine. So that its coefficient is not same. Now what is my actual value of the t? One eigenvalue is 0, other eigenvalue is my 2, and third is my minus of. Fine. If I consider this simple matrix, then what is my t square? What is the eigenvalue? 0, 2, minus 2 are the eigenvalues of the A. What is the eigenvalue of the t square? 0, 4, 4. Fine. What is the eigenvalue of the 4i? 0, 4, 4, 4. If I subtract them, what is the eigenvalue of their subtraction? It will be 4, 0, 0. It means g of t could be like of this 4, 0, 0. Below and clearly say that this is not my 0 matrix. So but he said it's a 0 is my false state. I hope you can easily understand that. You can consider any of the alpha 1 and alpha 2. I can simply take for this simply calculation, you may consider this as a alpha 1 and alpha 2 as here. Like if I solve for you, if I simply take alpha 1 is 1, alpha 2 is my minus 1, then this number will be x square minus 1. So g is my x square minus 1. So this number will be my 1 minus 1. Eigenvalue will be 0, 1, minus 1. Eigenvalue of the t square will be 0, 1, 1. Eigenvalue of the I will be 1, 1, 1. If you subtract them, what are eigenvalues? 1, 0, 0. So if this matrix has the eigenvalue 1, 0, 0, it means the matrix could be like of this nature, which is clearly say that it's a non-zero. Fine. Now look at the second study. What is the second study said you? Suppose 0 is the eigenvalue with at least 2 linearly independent eigenvector. What is the at least 2 eigenvalue? That's a geometric multiplicity is my 2. And we all know algebraic multiplicity is greater than or equal to here. So it means algebraic multiplicity can be 2 or 3. So firstly I consider the case of the 2. It means 2 occurring, eigenvalues are my 2. The third eigenvalue I consider as a 0. Then according to this, what is that? It is my x square, x minus alpha. Then what is the g of x? If I consider from here, this is x into x minus alpha, or I can written as x square minus alpha x. Then what is my g of t? T square minus alpha of t. Fine. So what is the eigenvalue of the t? 0, 0, alpha. Eigenvalue of the t square is 0, 0, alpha square. Eigenvalue of the alpha into t is 0, 0, alpha square. Fine. Whatever the value of the alpha, now you need a subtract. If I found the eigenvalue of the t square minus alpha t, it is my 0, 0, 0. So it means this value will be my here. So it means this matrix must be a 0 matrix. If I consider all the eigenvalues are 0, what is the meaning of that? This is my nilpotent matrix, and what is that? This is the x cube. So if this is a nilpotent matrix, so x square will also be a 0, because this is my gx in this case as compared to this. So in this case it is also be a 0. So it means this is my correct state. So once this is the correct statement, so only 2 is my correct statement, is the right answer of this exam. Okay, look at this another one. B is my 3 cross 5 such that this, what is that? This is nothing but my ax is 0, or you can say this is a nullity of A, because 0 is a 3-dimension vector. So nullity of B, that is a nullity of B is my 3. So can you find the rank of the B? What is that? This is a 5, number of the column vectors minus nullity of the B. So that is the rank is my 2. Rank is my 2. Then once the rank is my 2, the column span of the B is my 2 dimension is the correct state. Then first option is, okay, this is on the R cube. That means if you have the 3 cross 5 matrix, elements are my real numbers. Now if the elements are from the Q, what is happening on the matrix? Nothing is there. That the rank will be the same. Rank will be my same. That means nullity is my same. If rank is same, nullity is same, so this is again a 0. So they are talking about the nullity of the B when vector is from the Q. Then again it's a 3-dimension is the correct answer. Okay, then is the injective 1, 1. How you can prove the 1, 1? If you prove that kernel of T is my 0. That means if you prove that nullity of T is my 0, then it's a 1, 1. Now it's a B transpose. What is the rank of the B transpose? We all know rank of the B and the rank of the B transpose both are same. So this is my rank is my 2. So this is my 2. And what is the nullity of B transpose? Number of the dimensions are my 3. So 3 minus rank of the B transpose. It is my 1, which is non-zero. It means it is not 1, 1. So this option is cancelled. Look at this one. Again, it's a 1, 1. So you have to prove the kernel of this T is my 0. It means your target is to prove nullity of B into B transpose is my 0. Now we all know what is the rank of the B into B transpose. It's the same of the rank of the B, which is again the 2. So what is the nullity of B into B transpose? So what is that domain is 3, and minus rank of the B into B, which is 1, which is non-zero. So it is not a 1, 1, but he said a 1, 1. So the right answer is A and C are my correct options. That's a very simple, straightforward transposing. Okay, look at this next one. P10 is a vector space of the degree 10. So what is the dimension of this P of 10? 11. W1 is a subspace of all the polynomial up to degree 5. So what is the dimension of W1? 6. V2 is the subspace of all the polynomials. W2 is the subspace of all those polynomials from the P of 10 such that the coefficient is my 0. Okay, and what is the P1 is? All those polynomials from the degree of P5. This is my W1 and W2. So what is the dimension of this? Dimension of this is 11. There is only one condition, so it is a -1. So it is my here. Then W is my smallest subspace of, what is the smallest subspace is? We all know the smallest subspace is my W1 plus W2. Then the dimension of this, dimension of this, dimension of this, and so on. Very simple. Firstly, we can see about here. If I consider any of the element from here, if I say x4, this is my W1. Is it belongs to W2? No. Why? Because the W2 consists of all those subspaces, all those polynomial whose coefficient will be 0, like x minus x4. The coefficient is 1 minus 1, 0. But here the coefficient is 1, which is non-zero. So it means W1 does not contain in the W2. So this option is cancelled. Now, look at the intersection. What is a W? Now we can check about this W. How you can check about? Firstly, we can check about the dimension of W. So what is that? This is dimension of W1, dimension of W2 minus dimension of W1 plus W2. So what is the dimension of W1 and W2 is here. So we need to find it. So firstly, we will check about that. How you can check that? That is my here. So again, I think it's a very simple. How you can think about that? If I think about here, what is the intersection of this? Collection of all those polynomials from the P5, because the intersection is P5, such that this is my here. Fine. So what is the dimension of this? So what is the dimension of this is 5. Sorry, P5 is a 6th dimension. This is my 6. There is a one condition involved. So 6 minus 1 is my 5. So this is my 5. So dimension of the W1 is at most 5. This is 5. That's the correct. Is a correct statement. So this is my 6. This is my 10, and this is my x. So what is that? It's a 16. So x will be my 11. What is the meaning of that? Dimension of W1 plus W2 is nothing but my W is my 11. So dimension of W is at most 10. That's a wrong statement. Now W and V, this is my V vector space, and both are my finite dimension. So as I discussed in the previous example, if dimensions are same, you can see W and V are my same, because W also has, what is the dimension of the V is my 11. This is my V. Dimension of W is also 11. So both have my same. So the right answer is B and D are my correct options. Okay, look at this another one. So if T is my R cube to R cube such that characteristics polynomial is given to you. But remember, whatever the matrix, it is not given to you. Matrix can be anything which satisfies this property. So if I found the eigenvalues from here, plus of 2 is 0. So clearly says that 1 is the satisfied. So if I apply the Horner method, -3, 0, 2, 1 is satisfied, 1, 1, minus of 2, -2, and -2, 0. So what are the factor is? Lambda square minus of 2, minus of 2 is 0. Then one eigenvalue is 1, second is 2 plus minus 4 plus 8 over 2. So one eigenvalue is 1, second is it's a 12, 1 plus minus root 3. So it means 1, 1 plus root 3, 1 minus root 3. So what is the meaning of that? They are distinct eigenvalues. It means it is my diagonal matrix. So once A is my diagonal, so you can write the eigenvalue as of this nature. Fine. So clearly say that because it is a symmetric, it's a correct option. It is an upper triangular, that's the correct option. Now because there exists, so what is the meaning of the there exists? You can get at least one matrix. So I can simply say this is my A, whose polynomial is my this one, or you can say T. So one eigenvalue is there, one matrix you can found, so this satisfied. Now another option is third and fourth. There exists at least one matrix exists such that TV is equal to V. What is the meaning of that? 1 is my eigenvalue. You can see that one existence about the eigenvalue, but what is the given original matrix? It is not given to you. If I simply consider the matrix value as of 1 minus root 3, 1 minus root 3, 1 minus root 3, rest values are my 0. Clearly say that it satisfied this because this is the root of this equation. So this is also satisfied, but clearly says that 1 is not an eigenvalue. If T is my, because matrix is not given to you. So if you think about this matrix, I agree, you may think about that if this is matrix, then it is the right answer. But this one counter example is enough to disprove. If I consider this example, or you can consider any of this case, plus minus of this, both will satisfied here, and clearly see 1 is not the eigenvalue. So this option is cancelled. Look at the another case. There exists two linear independent vectors such that T is there. What is the meaning of that? They simply said 1 occurring 2 times, or you can say the geometric multiplicity of 1 is my 2. But again, you can see if you consider this example, 1 is not the eigenvalue, so geometric multiplicity is 0, is again the wrong number. If you consider this example, what is the geometric multiplicity of the 1? 3 minus rank of A minus I. So 3 minus 0 is my 3, which is not equal to 2. So again this option is cancelled out. So remember that there is a word of the there exists. So if you consider any of the matrix which satisfy this property, then the third and fourth options are cancelled. So I hope you can simply learn the various tricks and the solution of this linear algebra questions. So what I feel that there is a very simple linear algebra question asked in the June 2023 examinations. We will see the next lecture and we will describe the various other questions related to the real analysis, complex analysis and many more. Till then you can simply like, share and comments on my videos. Best of luck students. Happy learning.